Bismillah. Welcome to ThinkMath. Today, we solve a beautiful optimization problem involving geometry, differentiation, and modeling. A rescue team must transport supplies across a river. The river is zero point 0.6 kilometers wide, and the destination, point B, is 3 kilometers downstream. The team first travels by boat from point A to point D, then continues by truck along the road to point B. The boat travels at 12 kilometers per hour, while the truck travels at 45 kilometers per hour. Our goal is to determine the landing point D that minimizes the total travel time. Let x represent the road distance from D to B. That means the horizontal distance from point B to D is 3 minus x. Now, look at the right triangle formed by A, P, and D. The vertical side is 0.6 kilometers. The horizontal side is 3 minus x. Using Pythagoras, the boat distance AD is the square root of 0.6 squared plus open bracket 3 minus x close bracket squared. Time equals distance divided by speed. So the boat travel time is the square root of 0.6 squared plus open bracket 3 minus x close bracket squared divided by 12. The truck then travels a distance x at 45 kilometers per hour. So the truck travel time is x over 45. The total travel time function becomes t of x equals the square root of 0.6 squared plus open bracket 3 minus x close bracket squared divided by 12 plus x over 45. To minimize the total time, we differentiate. Differentiating carefully using the chain rule gives t prime of x equals negative open bracket 3 minus x close bracket divided by 12 times the square root of 0.6 squared plus open bracket 3 minus x close bracket squared plus 1 over 45. For an optimum value, we set t prime of x equal to 0. Rearranging gives 1 over 45 equals open bracket 3 minus x close bracket divided by 12 square root of 0.6 squared plus open bracket 3 minus x close bracket squared. Cross multiplying and simplifying eventually gives x approximately equals 2.84 kilometers. So the optimal strategy is to land fairly close to point B and use more of the faster road transportation. This makes intuitive sense. The truck is much faster than the boat, so we want to minimize time spent in the water. And that is a beautiful example of optimization using geometry and calculus. Follow ThinkMath for IB, A-Level, AP, and IGCSE Advanced Math.